Let's consider, as I said during the discussion earlier, that we would be having a large number of applications in our day-to-day life. Wherever we go, whatever we do, whatever fun or frolic we have, all these things, whatever entertainment we have, involves a machine. So we have few application-based questions that have been put across. Let's study them one by one. First one, why do metal cutters have longer handles? Have you all seen metal cutters? If you go to an industry, they have the huge sheet of metal that are being cut by cutters. Those are called as shear cutters also. Why is it that they have longer handles than the cutting edges? It is because longer the effort arm, less is the effort that is required. Isn't it true? We have studied mechanical advantages, effort arm upon load arm. So greater the effort arm, more is the mechanical advantage. That means less is the effort required. Hence, the metal cutters have longer edges. Second one, in spite of gain in force for a single movable pulley, yet it is impractical to use. While starting the single movable pulley, I did tell you that we are applying the effort in the upward direction. When we are applying effort in the upward direction, it becomes an impractical machine. But still we are having the gain in force. When we are having gain in force, means the effort required is load by 2, half the load. So we are applying less force to lift heavier load. But at the same time, since it is against gravity, it is inconvenient for us to lift the particular load, and hence we say that such type of pulley is an impractical machine. Class 3 levers cannot lift heavier loads. Why? You know what is class 3 lever? In class 3 lever we have the fulcrum, the load and the effort placed in such a sequence that effort is between the load and fulcrum. That means which arm is the longest arm? The load arm is the maximum arm or the largest arm. So if we have load arm maximum, mechanical advantage is effort arm upon load arm. Greater the load arm, less is the mechanical advantage. So because of this mathematical relation, MA is equal to effort arm upon load arm. Greater the load arm, less is the mechanical advantage. Next one. Which class of levers do the following devices classify into? First one, nail cutter. Nail cutter, we have the fulcrum between the load and effort. Nutcracker, the load in between fulcrum and effort. Sugar tongs, we have the effort applied between the load and fulcrum. Wheelbarrow, the load in between fulcrum and effort. Oar of a boat. Have you gone for rowing a boat ever? If you see that, we have the oar that is resting on the pedal, and then we oscillate or rotate the particular oar so that our boat moves forward. So again there we have the fulcrum in between, the load at one end, the effort at the other end. We have an effort of 500 Newton is applied through a distance of 50 centimeter. That means the distance traveled by the effort is 50 centimeter. If efficiency of the machine is 90%, 90%, and the load moves through a distance of 4 centimeter, that means the displacement of load is given as 4 centimeter. You're asked to find out the velocity ratio, the mechanical advantage, and the useful load lifted. In this case, we can find out the velocity ratio. While doing velocity ratio, we did derive an equation in terms of displacement, because when these displacements are traversed in the same time interval, velocity ratio is also called as displacement ratio. So we use the relation velocity ratio is equal to displacement of effort upon displacement of load. We are given both the quantities, so we divide 50 by 4 to get the velocity ratio as 12.5. Coming to percentage efficiency. You are given the percentage efficiency is 90%. We are asked to find out the mechanical advantage. So we use the relation percentage efficiency is equal to mechanical advantage upon the velocity ratio multiplied by 100. If I substitute the value, I get 90 upon 100 is equal to mechanical advantage divided by 12.5, giving me mechanical advantage equal to 11.25. Again, being a pure ratio is a unitless quantity. We also have the relation for mechanical advantage as mechanical advantage is equal to useful load upon the effort applied. We just now found out the mechanical advantage. Mechanical advantage is 11.25. We are asked to find out the useful load. We also know what the effort applied is given as 500. Using these values, we get the useful load as 11.25 multiplied by 500, which is equal to 5625 Newton. So in this way, we can definitely calculate the velocity ratio, mechanical advantage, and the useful load. So basically, we are just playing about the relations which are concerning the load, the effort, the displacement of effort, displacement of load, velocity ratio, mechanical advantage, efficiency. Let's try another one. A handle of a nutcracker. Now we are going into a practical based example. The handle of a nutcracker is 16 centimeter long. That is the total length from the fulcrum to the end of the nutcracker is 16 centimeter long. A nut is placed 2 centimeter from its hinge. That's a fulcrum. So 2 centimeter from the fulcrum, we are placing the nut. If a force of 4 kgf, I am applying a force of 4 kgf, is applied at the end of the handle, so as to have least effort that is required. End of the handle to crack it, what weight is simply placed on the nutcracker will crack it. Question says, what weight if simply placed on the nutcracker will crack it? So we have a nutcracker is nothing but lever of second order, in which case we have the load between the fulcrum and effort. So if we take moments about the fulcrum, if I take the moments about the fulcrum, I get 2 upon 100 multiplied by F is equal to 16 upon 100 multiplied by 4. As a result, I get F is equal to 16 multiplied by 4 multiplied by 100 divided by 2 multiplied by 100, leaving me F equal to 32. So therefore, the force that is required to be placed on the nutcracker amounts to 32 kgf. How about the next one? A man raises a load of 360 kgf. A man raises a load of 360 kgf using a block and tackle system in which there are 3 pulleys. The moment we see 3 pulleys, what do we conclude? Velocity ratio of such a system is equal to number of pulleys equal to 3. If the efficiency of the system is 60%, what effort is applied by the man? I have velocity ratio equal to number of pulleys equal to 3. I have mechanical advantage is equal to velocity ratio multiplied by efficiency. That is 3 multiplied by 0.6. That is 1.8. Also I have mechanical advantage is load upon effort. So therefore I have 1.8 is equal to 360 upon the effort. As a result, I get effort is equal to 200 kgf. So the amount of effort that is applied to lift the load of 360 kgf is 200 kgf. Let's consider this one. A crowbar of length 120 centimeter. We studied a crowbar. A crowbar is nothing but a lever which is used to dig the roads. A crowbar of length 120 centimeter has the fulcrum situated at a distance of 20 centimeters from the load. So the distance between the load and the fulcrum is 20 centimeter. You're asked to calculate the mechanical advantage of the crowbar. Mechanical advantage of crowbar is nothing but length of effort arm upon length of load arm. So we have crowbar as an order of first order lever. We have the mechanical advantage as length of effort arm upon length of load arm. Substituting the value, it is 100 upon 20. That is equal to 5. A very simple example to solve, but yes, could be asked. The next one, an effort of 6 kgf is applied on the machine through a displacement of 90 centimeter, 90 centimeter. When the load of 100 kgf moves through a distance of 4 centimeter. So we are seeing that the load is being lifted through a distance of 4 centimeter. You're asked to calculate the velocity ratio. You're asked to calculate the mechanical advantage. You're asked to calculate the efficiency of the machine. We know velocity ratio in terms of displacement ratio also. So velocity ratio is nothing but displacement of effort upon displacement of load. Given both the values, we substitute. It works out to be 90 upon 4. That is 22.5. Again, being a pure ratio is a unitless quantity. So there are no units for velocity ratio. So we just say velocity ratio is equal to 22.5. Second part is mechanical advantage. When we are asked to find out mechanical advantage, we use the relation load upon effort. Given the load, given the effort, we substitute, we get 100 divided by 6. 100 divided by 6 is 16.67. Again, pure ratio, unitless quantity. Percentage efficiency. Talking about percentage efficiency, it is nothing but MA upon VR multiplied by 100. We just now have obtained the MA. We have obtained the VR also. We substitute both the values as 16.67 divided by 22.5 multiplied by 100. That works out to be 74%. So the efficiency of the machine is 74%. How about this example, wherein we have a wheelbarrow that is being used in construction sites. In the figure, we have a stationary wheelbarrow with a CG at point A. CG is nothing but center of gravity, an arbitrary point in the surface or in the object wherein the entire weight of the body is assumed to be concentrated. The wheel and the legs are in contact with the ground. The horizontal distance between A and F, that is the center of gravity and the fulcrum, is given as 50 centimeter, and that between B and F is given as 150 centimeter. That means they have given you the load arm distance and they have given you the effort arm distance. What is the direction of force acting at A? And also they are asking you to name the force. Now, the direction of the force that is acting at A will always be directed vertically downwards towards the center of earth. Why is that so? Because weight of an object always acts towards the center of earth. And the name given to this type of force is called as the load. Second question they are asking, what is the direction of minimum force that is applied at end B to keep the leg off the ground? Also, they are asking you to name the force. In this case, the direction of minimum force that is applied at end B will be opposite to that of A. So the direction will be in the upward direction and the force will be named as effort. Let's consider the third sub question over here. The weight of the wheelbarrow is 15 kgf and it holds sand of weight 60 kgf. Calculate the minimum force required to keep the leg just off the ground, given acceleration due to gravity as 10 meter per second square. We have the total load as 60 plus 15, that is 75 kgf. We have the load arm distance, that is 50 centimeter. We convert it into meter, 0.5 meter. We have the effort arm as 150 centimeter, that is 1.5 meter. Applying the law of levers, we have load into load arm is equal to effort into effort arm. Substituting the value, 75 multiplied by 0.5 is equal to effort multiplied by 1.5. We get the effort required as 25 kgf. How about this one? In a block and tackle system of pulleys consisting of 3 pulleys, we have the load of 75 kgf that is raised by an effort of 25 kgf. You are asked to find out the mechanical advantage, the velocity ratio and the efficiency. Mechanical advantage is load upon effort. which is 75 upon 25 equal to 3. Velocity ratio, number of pulleys. Since we said that this system has got 3 pulleys, mechanical advantage is equal to 3. Velocity ratio also equal to number of pulleys, that is equal to 3. Efficiency is mechanical advantage upon velocity ratio, that is 3 divided by 3, that is 1. In terms of percentage, percentage efficiency equal to 100%. Let's go on to another one, wherein we are considering an inclined plane. A smooth plane AC is inclined to the horizontal at an angle of 30 degrees. So the angle of inclination is given as 30 degrees with respect to the horizontal. Length of BC is given as 50 centimeter, 50 centimeter. Length of AC is given as 100 centimeter. That is, length of the hypotenuse is given as 100 centimeter. You are asked to calculate the mechanical advantage, the velocity ratio, and the efficiency in terms of percentage. Since ABC is a right angle triangle, the hypotenuse is the longest side, which is 100 centimeter. We have sine theta as length of BC upon length of AC, which is 50 divided by 100, that is 1 upon 2. Mechanical advantage is 1 upon sine theta, cosec theta, that is 1 upon 2, that is reciprocal of reciprocals, which is equal to 2. Velocity ratio is displacement of effort upon displacement of load, or in terms of the right angle triangle, it will be length of incline upon vertical height. Length of incline upon vertical height, that means 100 upon 50 equal to 2. We have the MA equal to 2, velocity ratio equal to 2. So what should be the efficiency? Efficiency is mechanical advantage upon velocity ratio, that is 2 upon 2, that is 1. In terms of percentage, efficiency is 100%. How about this example? A very interesting example though. A machine is driven by a 50 kg mass that falls 4 meters in 2 seconds. That means the distance travelled by the load is given as 4 meters and the time it takes is 2 seconds. It lifts a load of 250 kg. It lifts a load of 250 kgs vertically upwards. That means it is the displacement of load that is given to you. Taking acceleration due to gravity as 10 meter per second square, you're asked to calculate the force exerted by the mass. Second, work done by the falling mass if its displacement is 4 meters. Third, the power input of the machine. And fourth, the power output of the machine if its efficiency is 60%. Talking about the first part, the falling mass is 50 kg. Therefore, the force that is exerted can be given by Newton's second law of motion. Force is equal to mass into acceleration due to gravity. That is 50 multiplied by 10, that is 500 Newton. Work done by falling mass is given by force multiplied by displacement. We have studied it in the first chapter, the mathematical relation for work done as force into displacement. So force multiplied by displacement, that is 500 multiplied by 4, equal to 2000 joule. We are also asked to find out the power input of the machine. Power input of the machine is given by work done upon time. We just now calculated the work done. We have the time, so we substitute over there as 2000 joule divided by 2 seconds, resulting in 1000 joule per second or 1000 watt. Talking about efficiency, we can have efficiency as power output upon power input. We given the value of efficiency, we are given the value of power input, we can obtain the value of power output as power output is equal to efficiency multiplied by power input. Substituting the value, power output is equal to 1000 multiplied by 60 divided by 100. 1000 multiplied by 60 divided by 100 equals to 600 watt. So the power output that is obtained from this system is 600 watt if the system is 60% efficient. So in this case, we have seen that we have used the concept of force, work, power, and then the efficiency. So we do have integrated problems wherein we do merge the concepts from the first chapter to the second chapter.